This is Wild Maths.
Right, reduction to linear form, which is one of the more difficult new topics. So, we've been given a sketch of this function, which is an exponential function. And the idea is we have to think about how it's gone from an exponential curve into a logarithmic curve and turned it into a straight line. So, first bit is we need to find an equation that describes that line. So we're going to need a line equation that has log base 10p and t as our variables. And the way we're going to do this is to take a logarithm of the function that they gave us originally. So we're going to log both sides of that. So log p equals log of ab to the power t. Then we're going to split up the term on the right hand side into two separate terms using our multiplication addition rule for logarithms. Then we're going to use the power rule to bring that t down the front. Now you can't bring the t down until you've split up the two terms because a is not to the power t. So now we're going to compare that equation to the equation of a straight line, y equals mx plus c. And because t is our x variable, our gradient is going to be log b and our intercept is going to be log a. So intercept there is 5, which is log a. And our gradient log b is equal to 1 over 200. So the last thing we need to do is just to write it out in terms of the actual graph in front of us. So we're going to get log of p equals 5 plus 1 over 200 times t. Which you probably could have just done by looking at the y and x axes and what they give us as the gradient and intercept, but the logarithms we did there is going to help us in the next bit of the question. So we've already established that the intercept is log a and the gradient is log b, so we're going to go from logarithmic to exponential form to solve those. So it's 10 to the power 5 equals a, so a is 100,000, and we can do the same for our gradient as well. So log to the base 10 of b is equal to 1 over 200. So 10 to the power 1 over 200 is equal to b. Which gives us a value of about 1.011. Okay, so the last bit is to basically talk about modelling. So we need to decide what these things actually mean. So constant A is the y-intercept. And if we look back at the original question, it says the town's population is what's on the y-axis. So the value of A is going to be the population at t equals 0, so it's the initial population. Constant b is the gradient, and we know that the gradient here is representing the rate of change of p with respect to time. So our constant b is going to be the change in population over time. So that's why I'm writing it now. So the gradient is the population, or the proportional population over time. And constant A is our initial population.